graph a linear equation? Well, not always the simplest, but it takes 2 points. You must have at least 2 points. Sometimes they'll use a third point just to make sure it falls on the same line. So sometimes they'll use the intercept. If you've got an equation like 2x plus 3y equals 6, this is going to have really nice intercepts. Your x-intercept where y is 0, you just solve 2x equals 6, leave the y term out. That's going to give us x equals 3. So the x-intercept would be the point 3, 0. You know, if you put in 3 for x here and 0 for y, you will have 6 equals 6. And the y-intercept is where we let x equal 0. That's going to wipe this out. So you've got 3y equals 6. Divide by 3. Y equals 2. The x was 0. The y is 2. So that's going to be the point 0, 2. So we've got 2 points. We can graph those over 3 up 0, over 0 up 2. And there's our line. But a lot of times, if one or both of these is a fraction, the technology that we're using will not let us graph a fraction. It's because if it went on a sliding scale where you could just have your cursor anywhere you wanted, you'd never be able to hit exactly 2. It'd either be 1.9 or 2.1 or something like that. So the technology will typically only let you land on integers. A second way to graph a line is to use the slope as the means of getting your second point. Now your slope is what they call the rise over the run. I kind of like to call it up and over. Your slope is a numerical measure of whether the graph is going up or down. Any graph that, as we look at it from left to right, any graph that's going up has a positive slope. Any graph going down, going left to right, has a negative slope. If it's a horizontal line, perfectly flat, so it's not going up and it's not going down, so it wouldn't have a positive slope or a negative slope. Here the slope is 0. That makes sense? And if we have a vertical line, a line that goes straight up and down, you can't really say whether this is going up or down because it's just going straight up or down. So as the slope is flat, the slope is 0. As it starts to go up a little bit, the slope is a positive number, but a small one. And as it gets steeper and steeper and steeper, the slope becomes a larger and larger number. Larger and larger, larger and larger. When it gets straight up and down, it is so steep that we can't measure it. And the slope of a vertical line is undefined. Now in math, anytime you hear the word undefined, that means somebody tried to divide by 0. And that actually is the case here. And I'll show you in a minute. So for any line, this would be a line with a positive slope. This would be a line with a positive slope. This one's bigger. The slope is the ratio of how far you go up and then how far you have to go over to get back to the line. So it's this distance over this distance. They call this the change in the y. The y tells you how high up to graph a point. This is called the change in the x. The triangle, the delta, Greek delta, means the change. This line goes up faster, but not over as far. This point, this line here, would go up really fast and then just over a little bit. So the slope is the ratio between how high it goes up and how far it goes over, and the up part goes on the top of the fraction. So how far you go up to how far you go over, that's why the steeper it is, the bigger the slope is going to be. Now, one way to get the actual number that we use, well, the only way to get the actual number that we use, is to get the difference between the x values and the difference between the y values. So this is delta x, this is delta y. If this point is the point x1, y1 to represent the x and the y from the first point, and this is x2, y2 to represent the x and the y from the second point, and it actually works regardless of which one you designate as the first and the second point. But this value would be x1, this value would be x2. This is going to be y1, this is going to be y2. See, here's the y2, here's the y1, x2 and x1. So the difference in the y values is one y value minus the other y value, and then the corresponding x value minus the other x value. These two have to come from the same point. As long as they come from the same point and you watch your signs, you'll got it. So if we want to find the slope between, say, 3, -5 and -2, -7, if we call this one x1 and y1 and this x2 and y2, and our formula for our slope is the difference of the y's over the difference of the x's, then y2 would be -7. Here's the minus from the formula. y1 is -5, so I've got -7 minus -5. So here's the second y, here's the first y, here's the minus from the formula. Same thing with the x's. I got to use the second x minus the first x. Now, the human brain cannot comprehend minus a negative. Anytime you ever see minus a negative, take those two negatives and make one plus out of it. -2 minus 3 is -5. -7 and a +5 is -2 over -5 is the same thing as a +2/5. If instead we had started with the other y first. Instead of the -7, I started with the -5. So I put -5 minus -7 over, now I'd have to put this x first because it has to be the one that matches up with that y. So this would be 3 minus -2 minus a negative becomes plus, always and forever. Same thing down here, becomes a plus. -5 and a +7 would be a +2. 3 plus 2 is 5. I get the same slope. Now the great thing about the slope is if the slope is 2/5, then that means every time you're on the line and you go up 2, because it's +2, and right 5, because it's +5, you will be back on the line. If I looked at these 2 points, if I've got over 3 down 5, and then -2, 7, -7, sorry. Notice that this would indeed have a slope where if I were to count up 2 and then over 1, 2, 3, 4, 5, it does put me back on the line. And that would actually happen from anywhere on the line.